Hello everyone, welcome back to our maths lesson. So today we are going to continue with our speed time graph. So let's get started and get ready with your notebook also. Okay? So for today learning objective is that you should be able to calculate the area under the graph. And then these are the steps. The first one, you have to shade the wanted area. Second, you have to label the dimension. Third, you have to calculate the area under the graph. Fourth, you have to give your final answer as distance is equal to the value of the area under the graph. So let's get started. Previously, we have learned that from speed time graph, we can describe the movement of an object. Also, we can find the speed of the object traveling, and also we can calculate the acceleration of the object from the gradient of the graph. So now we're going to continue for our speed time graph, which is distance travel. To calculate the distance travel, we have to calculate the area under the graph. So this is just a recap on how to interpret speed time graph. So like I said, what else can we get from a speed time graph? So we can get distance traveled. The distance of an object can be calculated by working out the area under the graph. The distance is measured in meters. So for example, we have a speed time graph like this. Okay, the question wants you to calculate the distance traveled. So the distance traveled, which is from here to here, which is a shape of a triangle. So next you have to label all the dimension and then apply the formula. So the formula of the triangle is half time base times height. So once you calculate the area, you'll get the distance traveled from here to here. Okay, so what if you have this type of speed time graph? So the object is moving with a constant speed. The area under the graph will be a rectangle. So label the dimension, and then you have to apply the area of rectangle, which is length times breadth. Alright? So this is how you calculate the distance. Alright, so let's start with an example. So for example, we have a speed time graph for like this. So the task one is that how far did Hamilton travel in the first 6 seconds? So the first 6 seconds is from here to here. Okay, so it will be a shape of triangle. So shape under the graph for the first 6 seconds is a triangle. The area of this triangle is equal to the distance traveled in the first 6 seconds. So we know the area of triangle is half time base times height, and the base is 1, 2, 3, 4, 5, 6, and the height is 1.8. So once you calculate, you'll get your distance to be 5.4 meter. Okay? So next, task number 2. How far did Hamilton travel when at a constant speed? So constant speed will be from here, from 6 seconds until 12 seconds. Okay, so this is a constant speed, which is 1.8. So the area under the graph will be a rectangle. So the shape under the graph, which is a rectangle, is equal to the distance traveled while traveling at the constant speed. Alright, so now what I want you to do, please pause this video and try to calculate the area under the graph for this constant speed. Okay, so I believe you have done this part already. once you calculate, you'll get your answer to be distance is equal to 10.8 meter. Okay, if you get it wrong, please double check your working. So next, task number 3. How far did Hamilton travel between 12 and 15 seconds? So 12 and 15 seconds is from here until here. So once you shade the area, it will be a triangle. So the shape under the graph of this period of time is a triangle. The area is equal to distance traveled between 12 and 15 seconds. Alright, so now please pause this video and try to calculate the area for triangle. Okay, I believe you have calculated everything sudah. So now the area of a triangle is half times base times height, and you'll get your answer to be distance is equal to 2.7 meter. Okay, so task number 4. What is the total distance traveled by Hamilton? So what if the question asks you to find or calculate the total distance traveled? So total distance traveled will be from 0 to 15. So you have to calculate all the area under this graph. Okay, in this case we have done that already. So we know that from 0 to 6 is 5.4 meter, from 6 to 12 is 10.8 meter, and from 12 to 15 is 2.7 meter. The total distance traveled by Hamilton is equal to the whole area under the graph. Alright, so now pause this video and try to calculate the total distance traveled by Hamilton. Okay, so I believe you have calculated everything. So to find or to calculate the total distance, we just need to add all these three together, and then the total distance is 18.9 meter. So from 0 to 15 seconds, Hamilton traveled for 18.9 meter. Okay, that is how we calculate the area under the graph. Alright, so now please proceed to example 1 inside your notebook. The diagram shows the speed time graph of a car which accelerated at a constant rate from 0 meter per second to 15 meter per second in 10 seconds. So from here to here, it remained at a speed of for 10 seconds before decelerating at a constant rate to stop in 5 seconds. Okay, first find the total distance traveled in 25 seconds. So from here to here. Next, calculate the average speed for the whole journey. C, distance traveled covered in the first 12 seconds. So from here to here, you need to calculate the distance. Okay, so now please pause this video and try to solve example number 1. Okay, so I believe you have done this already. So next, proceed to example number 2. The diagram shows the speed time graph of a car starting from rest. Given that the total distance traveled in 2 seconds is 430 meters. Find the value of V, the maximum speed reached by the car, which is this one, and B, the distance traveled in the first 18 seconds. So from here to here. Okay, so now pause this video and solve example number 2. Okay, very good. I believe you have done example 2 already. Okay, so once you complete everything, please submit your work to me. Alright, So that's it, everyone, for our class today. Thank you very much. See you next lesson.